Hello all, this is our entry for Tigergraph challenge. The entry name is Cancer Variant Analyzer. So this is a different problem that we are specifying. It's our problem of our own. So the area is cancer is a leading cause of death worldwide, accounting for nearly 10 million deaths in 2020. The most common in 2020 in terms of cancer were breast cancer, 2.226 million cases, lung cancer, that was 2.21 million cases, colon and rectum cancer, 1.93 million cases, prostate cancer was 1.41 million cases, skin cancer non melanoma was 1.2 million cases, and stomach was 1.09 million cases. Now, what's the solution we are proposing? So this is a comprehensive Tigergraph database for annotating driver and passenger mutations in terms of cancer, to study cancer better and to have a hierarchy based tool that helps us to find the linkages between different mutations. This is the tool that we are proposing. The application allows us to view relationship between gene mutation and cancer. So this is the schema of our graph. Now you can see, like, we have used all the images that were completely free, and we have used it to make the schema. So first let us find what is the main thing that we are doing. We are trying to find a relationship between a gene and cancer. Okay, so it's going through the basic steps where the gene has a normal gene position right now, and when there is a rapid change in the gene position, it goes to a peptide mutated position. Okay, so there is a peptide position change when the gene changes from normal to mutated one, and these evidences has been provided by different researchers that have been built over the years, and accordingly it has given a hierarchy of 1 to 4, 1 being the highest, 4 being the lowest. And accordingly we have also mentioned where the peptide position has changed, and with that the mutation changes that has occurred, there is a cancer that has happened. Okay, so this is the schema, and after that we have used also another notebook that is known as Cancer Variant Notebook, which directly drives the API from myvariant.info. This is the largest info of all the cancer related mutation that has occurred, and we have used it. So let's go through the demo of the application right now. Now we are into Tigergraph. You will just open up the Tigergraph instance itself. You can just go to the design schema where you get all the information of the projects. Here is a schema. Now if we go to load explore graph, we have this particular thing appearing where you can do all of the analysis in a graph studio. Now I am just selecting the mutated gene. You can select others also. I am just mutated gene. I selected mutated gene, and it is 5 layers deep. Now if I just click on pick vertices, you have these options opened up. Now these are the gene positions, the mutated gene positions that are there. If I just double click on it, you will have all the relationship that has occurred, like the peptide change, where exactly it has happened. If I just reduce the size of the particular image that we have, or the graph that we have, and we have level of evidences that has been meant for a particular mutated gene, and the peptide position has also changed accordingly, because we have only considering the mutated gene we have. Similarly, if we can click on other branches too, you will get all the information. Okay, so if I just minimize it, you will see this kind of graph. We are using the capabilities of graph itself. Now we can also have a tree-like approach. So tree-like approach will show us how and where we stand, and all the information. If we just expand it, you will also get all the information. So this is the way you can dig deep into cancer data, and it helps us to bind from exact location where the cancer has occurred, and which normal where the mutation has happened accordingly. Okay, and apart from that, we have also used this myvariant API that helps us to create another graph that we have done, using the IPython notebook, and we have created a graph for this named as cancer graph, that is found over here. The main graph is our do that graph, and if we see, click on cancer graphs. Yeah, you get the information, and let me just minimize it. So between different variant and the type of RSIDs that is there, this linkage has been created. Okay, so that is the entry for our application. We are working towards making it as a web app. Thank you all for going through it.